welcome back to Science Online. My name is Rajesh. In today's video, I'm going to talk about buffer solutions. This is for A-level chemistry students. At the end of this video, you should have the understanding of buffer solutions and how the buffers works. So let's start. As usual, before we go into the details of the topic, let's clarify a few terminologies we will be using today. Strong acid, weak acid. What is a strong acid? Strong acid are the acids which fully ionize in aqueous solutions. Say for example, hydrochloric acid is one of the strong acids. When the hydrochloric acid in an aqueous solution is completely ionized, completely broken down into H plus and Cl minus ions. So you're not going to have HCl molecules in a solution. So as you can see on the screen, if you have a hydrochloric acid in a beaker, the only ions in the solution is going to be H plus and Cl minus ion. So all of the H plus will contribute towards its pH. On the other hand, the weak acid. Weak acids partially ionize. Only a small portion of the acid breaks down into ions. As you can see on the screen, the example I'm using here is an ethanoic acid. It's one of the weak acid. It's broken down into ethanoate ion and H plus ion. As you can see, it's a tiny amount of H plus ion and the ethanoate ion is forming. The most of the ethanoic acid stays as a compound. Even though it's an ethanoic acid, if it's not broken down, the bigger portion which is not been broken down, it's not going to contribute towards the pH. This partial breakdown of this weak acid will be used in the buffer solutions a lot. So understanding this concept is very important for the next part. Buffer solutions. Buffer is a solution which can resist changes of pH when small amount of acids or alkalis added to them. It's very important to note it will only resist small changes. So it will only work when you add small amount of acid or alkalis. If you add too much, it may kill the buffer. Now let's see how the buffer works. I'm going to use CH3COOH, ethanoic acid, as my example again. So you can see the ethanoic acid broken down into ethanoate ion and then H plus ion. Since it's a weak acid, it's a reversible reaction. So let's see what happens when we add some acid to this mixture. If you are adding acid, it means you are introducing H plus ions into the solution. When you add H plus ion, these H plus ions from the acid react with CH3COO minus ion and going to create CH3COOH, which is the weak acid as a compound. So what are the changes happening? The adding H plus reduces the amount of CH3COO minus ions and increases the CH3COOH. But if you noticed, none of these changes the H plus concentration in the solution, and therefore there's no changes to the pH. Let's see if you are adding OH minus ions, alkalines. So when you add alkalines to the solution, you are introducing OH minus ions to the solution. So these OH minus ions are going to react with ethanoic acid, CH3COOH molecules. So it's an acid-base reaction. It's going to form CH3COO minus ion, ethanoate ions, and water molecule. Again, if you notice, what are the changes happening here? The amount of CH3COOH, ethanoic acid, coming down, and the amount of CH3COO minus ions are going up. Same as before, there is no changes to the H plus concentration in this example. And also, because this H plus concentration is not changing, the pH is not changing. Now, if I take you back to the adding acids to the buffer, as I earlier mentioned, when you add acids to the solution, it's going to react with CH3COO minus to form CH3COOH. But you remember, the weak acid disassociate partially, and when they disassociate, the amount of CH3COO minus ion and the H plus ions forming are very, very little. So the small amount of CH3COO minus and the H plus ions are in the solution. Therefore, you won't have enough CH3COO minus ions to take up all the H plus you are adding. In that case, the buffer might not work. We need an additional supply of CH3COO minus ions from some other sources. This is why we need a salt in this mixture. The salt must be made up from the same acid. The salt I'm using in this example, sodium ethanoate. It could be potassium ethanoate or it could be any sort of ethanoates. So sodium ethanoate, as you all know, salts will ionize completely. So if I add sodium ethanoate in this solution, in this mixture, it will completely break down to form CH3COO minus and sodium plus ions. Because it's a complete disassociation, you're going to have lots of CH3COO minus in the solution. So adding acids won't be a problem. This is the reason we need a salt in an acid buffer solutions. Now we have a functioning buffer. We can use the Ka equation. Ka equals CH3COO minus ion concentration times H plus concentration divided by the CH3COOH concentration. The important point to note here, not like weak acid calculations where we say the CH3COO minus ion concentration is equal to the H plus concentration. We cannot use that concept here because, as you know, CH3COO minus came from the salt in the buffer solution, and also the concentration of CH3COO minus ion is significantly more compared to the H plus concentration because it came from the salt, not from the weak acid. Also in buffer solutions, we make two assumptions. The first assumption is, as I mentioned earlier on, the CH3COO minus ions only came from the salt. We are ignoring the tiny amount of ethanoate ions came from the weak acid compared to the one came from the salt is a negligible. So first assumption is CH3COO minus ions only came from the salt. The second assumption, because only a small amount of weak acid, CH3COOH, ethanoic acid, is disassociates during the process, we maintain the concentration of CH3COOH same throughout this process. So that's the second assumption. The concentration of ethanoic acid remains the same. What we did today is an acid buffer and how it works. In your exams, the questions in buffer solutions are heavily marked. You usually get questions on every single exam papers. And just the calculation part of the question usually gives you about 6 to 8 marks. 6 to 8 marks in A-level exam is a gold dust. It may even change a grade. So understanding how the buffer works helps you to work out the questions and understand what's the mechanisms behind it. Hope you find today's video is useful. Until I see you in another video, bye to everyone.